Today we're going to be talking about how intermolecular forces affect solubility. First, we're going to dissolve 1 tablespoon of salt, which is sodium chloride, into 500 milliliters of water. So we're going to stir it around, and as we can see, the salt is dissolving into the water. The reason that the salt is able to dissolve in the water is that water is a polar compound. A polar compound, like water, has a slightly negative and a slightly positive end. For water, the slightly negative oxygen atoms attract the positive sodium ions in the sodium chloride, and the slightly positive hydrogen ions attract the negative chloride ions in the sodium chloride. This attraction is called an ion-dipole attraction, and it is what allows this salt or sodium chloride to dissolve in the water. Next, we're going to dissolve vegetable oil, 125 milliliters of it, into 500 milliliters of water. We're going to pour our vegetable oil into the water and stir. As we can see, the vegetable oil is not dissolving in the water. The reason the vegetable oil does not dissolve in the water is that vegetable oil is a non-polar compound. The non-polar compound has dispersion forces between the molecules. It is not able to form any intermolecular forces with the polar solvent, which is the water. The water has intermolecular forces between its molecules. It has hydrogen bonding, dispersion, and dipole-dipole forces. They are not breaking to allow the non-polar oil molecules in between it. If we let it settle, we can see that the oil droplets are totally separate from the water and they have not dissolved. Now we're going to dissolve 50 milliliters of acetic acid, which is common vinegar, into 250 milliliters of water. The vinegar or acetic acid is a polar compound, just like water is a polar compound. This time, when we put the lid on, we're going to give it a shake. After allowing it to settle, we can see that in fact it did dissolve. The water was the solvent and the acetic acid was the solute. They dissolve because the polar water dissolves the polar vinegar or acetic acid. Like dissolves like. The water and the acetic acid form intermolecular forces between each other. They are able to form dispersion, dipole-dipole, and hydrogen bonding between each other and allow them to dissolve. Now, if we understand these concepts, we are going to be able to explain the following. If I have a glass here and I pour some vegetable oil into the glass, and I attempt to dissolve some salt or sodium chloride in my vegetable oil, no matter how much I stir it, you can see that the vegetable oil will not dissolve the salt or sodium chloride. Why is that? You think about it, use intermolecular forces to be able to explain what is happening here.